Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. This is CCNA Semester 3 Scaling Networks. We're talking about Chapter 1, Introduction to Scaling Network. This is Section 1.2, Selecting and Network Devices. So switch platforms. We have a fixed configuration switches. Features and options are limited to those that originally came with the switch. So for example, fixed configuration switches, it means that you can't change anything, that you can't add ports or remove ports. They have a fixed configuration. So if you buy a switch with 24 ports, that's it. You can't add any more ports. Or if you buy a switch with 48 ports, that's it. You can't add any more. Different from modular switches. So then we have a modular switch, like we say. Modular switches, the chassis accepts line cards that contains the port. These are obviously a bit more expensive switches. So here you can add more ports. So you can add more line cards with extra ports on them. So the difference from the size of them, for example, fixed platform, if I go back, these are very small switches. You can lift them. They're not heavy. 2960s, 2950s, 3550, 3560s, 3750s, and so on. These are the modular switches. They're quite heavy. You can't even lift them. So they're really big. Plus, they are for medium-sized or enterprise businesses. They have lines which you can add extra ports. Plus, they have a redundancy on the power as well, and the supervisor engine as well. So a redundancy in the power means that you can connect it to two different power supplies. If one power supply fails, the other one will take over. Some of the switches that we have is called stackable switches. These stackable switches, you can connect more than one switch together. So for example, here we have 4 switches connected together, and then it behaves like one switch. If we have, like, for example, if we connect the fixed platform, if I go back here, if I connect these switches together, I'm gonna lose a lot of ports. So I connect port from there to here, another port from here to here, and so on. So as you're connecting them, you're losing ports the users can be using. Plus, on top of it, the bandwidth, these switches, they will have an election. They will talk for themselves, send packets to like BPDUs for the network notifications and so on. So there's going to be wastage of bandwidth as well. So if we have a stackable switches, all these switches, we can connect them together, and then they will behave like one switch, and configuration will be once only. Port density. The port density of the switch refers to the number of ports available on the single switch. So for example, we can see here, I think this is 3750, it's 24 port switch, and this is 48 port switch. Then we have modular switches. Like I said, these are like huge switches. They can have up to 1000 and more ports per switch. Fixed configuration switches typically supports up to 48 ports on a single device. Modular switches can support very high density through the addition of multiple switch port line cards. For example, Catalyst 6500 switches can support in excess of 1000 switch ports. Large enterprise networks that supports many thousands of network devices require high density modular switch to make the best use of the space and power. So forwarding rates define the process capability of the switch by rating how much data a switch can process per second. So we can have here 24 gigabits per second traffic or 48 gigabits per second traffic. Switch product lines are classified by forwarding rates. Forwarding rates are important to consider when we select the switch. If the switch forwarding rate is too low, it cannot accommodate for full wire speed communication across all of switch ports. Wire speed is the data rate that each Ethernet port of the switch is capable of attaining. Data rates can be 100 Mbps, 1 Gbps, 10 Gbps, or 100 gigabit per second. Power over Ethernet. Power over Ethernet allows the switch to deliver power to devices over the existing Ethernet cabling. This is great. You don't need to buy an external power to power the IP phones or wireless access points. All of them, they will receive a power from Ethernet cable. This feature can be used on IP phones and some wireless access points. Power over Ethernet allows more flexibility when installing wireless access points and IP phones, allowing them to be installed anywhere that there is Ethernet cable. A network administrator should ensure that Power Ethernet features are required because switches that support our Power Ethernet are more expensive. Multilayer switches. Multilayer switches are typically deployed in the core layer and distribution layer of the organization switch network. Multilayer switches are characterized by the ability to build the routing table, support a few routing protocol, and forward IP packets at a rate close to that of layer 2 forwarding, so much faster than a normal router. So these layer 3 switches can have a routing table and can support routing protocols as well. Multi-layer switches can support specialized hardware such as application-specific integrated circuits, ASICs. ASICs, along with the dedicated software, the data structure can streamline the forwarding of IP packets independent of the CPU. Selecting the switch hardware. When we go and buy the switch, the first thing that we have to think is the cost. How much does it cost? The cost of the switch will depend on the number and speed of the interface, supported features, and expansion capability. Port density. Network switches must support the appropriate number of devices on the network. Power. It is common to power access point, IP phones, and even compact switches using Power over Ethernet. In addition to Power over Ethernet consideration, some chassis-based switches support redundant power supplies. Like we said earlier on, there's 2 power supplies. Some of them could have 4 power supplies. Reliability. The switch should provide continuous access to the network. Port speed. The speed of the network connecting on a primary concern to the users or end users. And the way the switch buffers the frames. The ability of the switch to store the frames is important in network where there may be congestion part for the servers or other areas of the network. And scalability. The number of users on the network typically grows over time. Therefore, the switch should provide the opportunity for growth. Switch platform. So we have, for example, we have a campus LAN switches. To scale network performance in an enterprise LAN, there are core, distribution, and access switches. Campus LAN switches platform include Cisco 2960, 3560, 3750, 3850, 4500, 6500, and 6800 series. These are campus LAN switches. Then we have a data center switches. A data center switches should be built based on the switches that promote infrastructure scalability. So here we are thinking about scalability. We're going to grow. Operational continuity and transport flexibility. The data center switches platform include new Cisco Nexus series switches and the Cisco Catalyst 6500 series switches. Then we have a cloud management. The Cisco Meraki Cloud Management access switches enable virtual stacking of switches. Service provider. Ethernet access switches features application intelligent, unified services, virtualization, integrated security, and simplified management. Then we have a virtual networking. Networking are becoming increasingly virtualized. Cisco Nexus Virtual Networking Switch platform provides secure multi-tenant services by adding virtualization intelligent technology to the data center network. Router requirement. Routers play a critical role in networking by interconnecting multiple sites within an enterprise network, providing redundant paths, and connecting ISPs on the internet. So, for example, we need a router if we want to break the broadcast domain, so broadcast containment. So, for example, here we have a broadcast domain in this left here, and then if we want to break that broadcast domain, we implement a router, and the router will not send broadcast from one network to another network. We need the router for providing security. So if one network is trying to access another portion of the network, then obviously it's going to go, if it goes through the router, then router will be able to implement something, a firewall or access list to provide the security. Logical grouping. So for example, we have an inter-VLAN routing. So we create the VLANs and we create engineering in one VLAN, accounting in one VLAN, and all that the router will have inter-VLAN routing. It will give us the ability to do inter-VLAN routing. So you can see everything is an access layer, and this router here is a distribution layer. So a router, or it could be a layer 3 switch. And location to communicate between ISPs, site A, site B, communicating over a wide area network. Routers can also act as a translator between different media types and protocols. For example, a router can accept packets from Ethernet network and re-encapsulate them for transport over serial network. Routers use a network portion of the destination IP address to route packets to the proper destination. So for example, once a router gets a packet, the first thing it is going to look at is the destination. Where is it going? Where is the destination? And then it's going to try and find the destination on the routing table to move the packet on. We have inbound versus out-of-band management. Out-of-band management is used in initial configuration or when a network connection is unavailable. So, or when you have a brand new router, first thing you're going to configure is called out-of-band. You pick a blue cable, you put it at the back of the router, and you start configuring it. You need a terminal emulation program like Teraterm or PuTTY, and you start configuring your router. That's called out-of-band because you're not using any bandwidth, and the router doesn't have any configuration for you to be able to configure. Configuration using out-of-band management requires direct connection, like I said, with a blue cable, or AUX. AUX implements you have to have a modem. So for example, remotely through the modem to configure that router. And terminal emulation client. So we have to have an application, terminal application, for us to be able to configure it. We can't use a command prompt. So we have to use a Teraterm or PuTTY or something. Then something we call inbound router configuration. Inbound is used to monitor and make configuration changes to network device over network connection. Configuration using inbound management requires at least one network interface on the device to be connected and operational, and telnet, SSH or HTTP or HTTPS to access the Cisco device. So for example, we can't do out-of-band management if it's brand new router. If it's brand new router, we have to go out-of-band configuration, put the console cable, give it an IP address. Once we have an IP address and we can ping that IP address, then we can do out-of-band management. Inbound management. So we can ping it, we can telnet or SSH to it. So out-of-band, no configuration, brand new router, you give an IP address, then we can do inbound configuration, which is we use in the bandwidth. We can telnet or SSH the router. Now we're going to go through some basic router CLI commands. For example, I got a router here, R1. It's got interface FA00, FA0/0, and the IP address 192.168.10.1/24. It lives on this network, 192.168.10.0/24. So first thing is to configure the host name of the root to router 1. So by default, the router has got a name just by router. We don't have to configure the host name, but it's good, advisable. So if you when you configure inbound management, when you say you are telnetting to 3 or 4 routers, you don't want all the routers to be called router. So for that reason, we change the name. We put the host name. So go to global configuration mode, and we type host name, and then whatever name we want to use. R1 in this case. R1. Now the name has to start with a letter and has to be at least maximum is 63 characters. There's no minimum. One character. And then you can't use spaces. So it has to be contiguous letters. You can use letters, numbers, or special characters as well. Then you can see when we change the host name to R1, the host name changes here. Now, the next thing we want to privilege mode. After we go to the user mode and we type enable, we should get a password. We should be challenged with a password. So for that reason, we will configure a password for privilege mode. So enable, secret, and then whatever password we use it. So while we're doing the training, we're going to use class only. Class and Cisco, those are the only 2 passwords you should be using while in training. Not in real life. On the real world, you should be using some very strong password, 8 characters minimum. Uppercase, lowercase, and then whatever. Use mixed password, mixed letters. Right. This is the MD5 encryption. This is very strong encryption. It's better than there's another enable password. So enable password, and then but that is being deprecated anyway. This password has it's used now. Disable domain lookup, so we have to go no IP domain lookup. So this is what it's gonna do is, if you, for example, type something that incorrectly, it's not gonna try and send a broadcast message. It's gonna try and resolve whatever you mistyped to an IP address. So for that reason, we disable the domain lookup. Encrypt all password. Now every password that we create is decrypted by default. It's clear text, not decrypted, it's clear text. So we would want to encrypt it, not this password. This password is encrypted by default. As soon as we create the secret is encrypted with MD5 password, MD5 encryption. But any other password, it will be decrypted by, clear text. This command, service password encryption, it will encrypt any password that is not encrypted by default. Set warning banner. Now we have to warn people from outside that if they come into our network, they have to be authorized. If they're not authorized, we will prosecute them. Do not put any welcoming words on your banner. So banner, message of the day, authorized users only. Well, here in the production network, you would contact your legal team and what you want to put in there. But you want to make sure that they know they will be prosecuted if they are not authorized to log into this router. Password for console and no timeout. So we have to go to the console line. So line console 0. As you can see that it has changed. The mode has changed now because we are in the specific configuration mode. So config -line. That means that we are in the console mode. And we type password Cisco. Now if we didn't have this command there, this password will be in the clear text. But because we have this command, this password will be encrypted. Login means that we are going to use this password for logins. Exec timeout 00 means that if you are idle in the router for forever, it's not going to log you out. By default is 10. This 0 represents 10 and this 0 represents seconds. So this 0 represents minutes and this 0 represents seconds. So by default is 10 minutes and 0 seconds. So if you for 10 minutes you sit idle, then the router will log you out. Like this, doesn't matter how long we are idle, the router will never log us out. Password for VTY lines, so we have to go to line VTY 0 to 4, password Cisco, and login. Login, this says use this password for logins. It could be login local, which we could use a local database, or we could use some authentication server like Radius and so on. But for now, we are just using this password. Then next challenge is interface IP address. So we have to go to interface G00. You see the prompt has changed. Config -if and give an IP address. Now, first of all, description. It's very, very important that you write the description. Description R1 to the LAN. Then we give an IP address. IP address, like we said, 192.168.10.1, and then the subnet mask. No shutdown. By default, all the interfaces on the router are down by default or shut. And you to bring them up or to enable them, you do no shutdown. The next thing is to enable a routing protocol. So for example, in this case, we are using EIGRP, router EIGRP1, and then network, whatever network you are advertising, 192.168.10.0. Before, I used to say to the student to do no auto summary. But with the version, with the 15.0, with iOS 15.0 and above, that command is the default. So you don't need to type no auto summary on EIGRP. Okay, next one, basic router show command. So if, for example, if you do show IP protocols, we can see the has changed OSPF. Okay, we can see the protocol that we are running for this router is OSPF. And it's a process ID of 1. So here we can see highlighted. We can see the router ID is 1111, and we are routing for these two networks. And then we can see the distance is default to 110, administrative distance. The next command, show IP route. For example, show IP route. It will display us what does our router know? What destination does it know? What's on the memory? Everything, all this is kept in RAM. So show IP route, first we can see the codes. Every route that we learn, it will have some code to how we learn that route. So for example, here we can see connected, directly connected root network 192.168.10.0 and local IP address of that directly connected network. So the interface IP address is 192.168.10.1. This local hasn't been here before, has been added to version 15.0 and above. It's been added. This serves a good, for example, the reason it's there is for if you communicate into the router, directly communication with the router. So it's there to help the router rather than to search the network if you are sending messages directly to the router. And then the next one is we learned root from our neighbor. A neighbor's IP address is 192.168.10.2. That's how we're gonna send it if we want to send anything to this network. The network that we learned is 10.1.2.1. This must be a loopback. Anyway, and we are sending it through serial 000. The next command is show IP OSPF neighbor. Show IP OSPF neighbor is displaying us who is our neighbors. So we have a neighbor with ID 2.2.2.2 with priority 0 and full state. Then a dash here we see that it means that it's probably a point-to-point network rather than a multi-access. So it means that we are not going to elect the DR or BDR. The time, the dead time. So our neighbor is going to send us hellos every 10 seconds. The dead time is 4 times hello, which is 40 seconds. So every 10 seconds we should see this dead time increasing. Now, if it falls below 30, well, you missed few hellos, 1 hello, and then if you continue to fall, you're going to lose adjacency with the neighbor. The next command is show interface serial 00. Now this command will show us the interface, the status, and the protocol, and then what's the IP address of this interface. There's some other good information here, but for now we just need to see that we have an IP address here and the status and the protocol, and whatever encapsulation we are using as well. You see HDLC for S00. For example, if the other side is using PPP, you're not going to be able to create neighbors. Show interfaces, show IP interface brief. This is a great command that will show us what interfaces we have on the router and what's the status and protocol. So for example, everything else here, fast Ethernet 00 and fast Ethernet 01, administratively down in both of them, and we don't have any IP address assigned. The serial 000 is got 192.168.10.1 and it's up, status and protocol is up, so it's functional interface. Plus we got another loopback, a virtual interface. And then the last one is show CDP neighbors. CDP neighbors is a great command if you want to build the topology. The CDP neighbor is layer 2 protocol. CDP is a layer 2 protocol, and it's going to show you everything they knows, all the neighbors they knows at layer 2, which is great to see if something doesn't work, if you have a connection with your neighbor. So if it says here the device ID is router 2, that's a name. A local interface is serial 000. Hold time 153. Now CDPs, they get sent every 60 seconds, and we're gonna 3 times hello. So every 60 seconds we send the CDP message. So 3 times hello is a dead time. And they here we're saying the capabilities of this device as well, plus whatever platform we are using. Some basic commands for the switch: erase the startup. Now the switch and the router, if you want to reset to the default or factory reset, you need to erase the startup configuration. The command is privilege mode command, erase startup config. You can see that S3 configured. We have we have a configuration. We don't want to put it as a default, this switch. The switch, we have to not just do that, we have to delete the VLANs database as well, because erase startup config is not going to delete the VLANs, the normal range VLANs. So we have to say delete VLAN.dat. This is stored in flash, so we have to delete the VLAN database as well. And then we have to reload the switch. After the switch has been reloaded, the name has changed to switch, and then to change the name to what we want, this is the default now, default factory configuration. We have to go to the global configuration mode by typing configure terminal, and in there we change the name, hostname S1. That's what requirement is. Password, set the password for privilege mode. So this is enable secret. Disable domain lookup. We said no IP domain lookup. Encrypt all passwords. Service password encryption. Set warning banner. Banner MOTD authorized users only. Password for console, no timeout like we did for the router. Password for VT white lines. These are the basic startup. So you should know every time you do a configuration, read these commands that you should be typing in. And interface IP address on the VLAN 1. Now, this is a layer 2 switch. So layer 2 switch is going to have one IP address, one interface, a virtual interface that you can assign an IP address. Usually, is VLAN 1 for the management, but you can change it to VLAN 99, for example. Now that IP address, we give an IP address so we can manage this switch, right? So the IP address that we're going to give is 192.168.2 and /24. So interface VLAN 1. Don't forget the description for remote management. IP address 192.168.10.2 and then the subnet mask. No shutdown, exit. Now if you can manage the switch locally, if we want to manage the switch from remote destination, now this switch needs to have a gateway, default gateway as well. So configure the default gateway. IP default gateway 192.168.10.1. Some show commands: show port security if we have enabled the port security in the switch. Show port security addresses, display all secure MAC addresses. Show interfaces, displays detailed information about the interfaces. Show MAC address table will display all MAC addresses the switch has learned. And then, like we did in the router, show CDP neighbor, display all directly connected Cisco devices. Okay, this has been Astrid Krasniqi. We went through CCNA Semester 3, Scaling Network, Chapter 1, Introduction to Scaling Networks. Thank you very much and hope to see you in the future videos. Bye-bye.